The ninth element on the periodic table of elements is fluorine. This is Norris Teaches Science with me, Mr. Norris, another physical science edition video, and today we're going to talk about atomic structures. And so your goal for this video is I can describe the structure of the atom and how the components are calculated. Before you continue with this video, you will need a periodic table with you so you can understand the examples. So pause real quick, get yourself a periodic table, and then come right back. So when we talk about atoms versus elements, it's really important to know the distinction. An element is a substance that cannot be broken down into a similar substance. So those things listed on the periodic table are all elements, like neon, my favorite element, gold, helium. Those are elements. An atom is the smallest particle of an element, and it's how we count the elements. We say that we have 10 atoms of helium. Not that there's 10 heliums, there's 10 atoms of helium. Now, the history of the atomic model. This is very, very quick. There's a lot more to it. But the first person you need to know is Democritus. He actually believed in atoms. This is from more Greekish times when they really thought everything was consisted of four main elements, fire, earth, air, water. He thought there were these other things that made up those components. And then, as you can see, it was just like a solid sphere. John Dalton made the theory of the atoms. His model of the atom didn't change much because we haven't discovered much about them. Then comes J.J. Thomson. He found the electrons, and he knew that atoms were neutral, so there had to be the positives and the negatives there. Ernest Rutherford found the nucleus. The nucleus is in the center here. Then came Niels Bohr. He discovered energy levels where the electrons lie. And then our current, more modern theory calls the electron cloud model, where there's probability about where the electrons are around the nucleus. Now, I mentioned some of these just now, but an atom can be broken down into three subatomic particles: protons, neutrons, and electrons. Protons are positive. I try to think of pro. Pro is a good thing. Its symbol is a P plus sign. In general understanding, it has a mass of 1 AMU. Right. A neutron, it looks like the word neutral, means it doesn't have a charge. Its symbol is an N. Sometimes you can see an N with a 0 on it. And its mass is 1 AMU as well. A proton and a neutron have about the same mass. So we're just going to say 1. Electrons are negatively charged. Electrons are negative. Its symbol is an E with a lowercase e with a minus sign. And they have a very extremely small mass that if I wrote it up here, you would be writing ones forever. So we're not going to write it. But just remember, electrons have a smaller mass than protons or neutrons. Now, the parts of an atom, I mentioned that we had energy levels and we had the nucleus when we talked about the model of the atom. The nucleus is the center of the atom. It's very small, it's dense, it's positively charged. You're going to find your neutrons and your protons in the nucleus. So your neutral charges and your positive charges. So that means the nucleus is positive. It's positively charged. All right. The energy levels, shells or orbitals, it can be said in any of these terms, go around the nucleus. You can see those as those blue lines in the picture. And your electrons are going to lie there. And so around the nucleus, the positive nucleus, is going to be this negative sort of shield or shells. And your electrons are lying there. Now, since we now know about protons, electrons, neutrons, we can look at a periodic table. Over here in this picture, this is called an element block. It has all the information about different elements. This element is oxygen. But we're focusing right up here at this number 8. That number is the atomic number, and it identifies the element. Not only does it tell what element it is, because there's only one element, that is 8, it also tells us the number of protons. That means oxygen has 8 protons. And it's at the top of the element block, as you see. But the secret that no one knows, since atoms are neutral, it also indicates the number of electrons. So oxygen has 8 protons and 8 electrons. Mass number is when you look in the element block, it's usually at the bottom. It's usually a decimal. It's the decimal number. And it's the sum of the protons and neutrons. Now it is a decimal, so what we do, we round to the nearest whole number. So 20.18 would round to 20. So that means 20 is the sum of the protons and the neutrons. If you remember, the top number tells us the number of protons. So there's a way that we can calculate it. We're going to talk about that on a future slide. And most times the mass number is at the bottom. So understanding an element block, if you have your periodic table in front of you, you can see this. At the top will be the atomic number. Then comes the element symbol. Usually it's the bigger thing in the element block. Here's the thing. If it's just one letter, that one letter will be capital. But if it's 2 letters, the first letter is going to be an uppercase. The second letter is going to be a lowercase. Make sure you write it like this, because if you wrote it like this, I would think there would be 2 elements there. Now, I also know that there's no element, just E. But in a sense, if someone's learning the element periodic table, they need to know where 2 elements end. So I could be like B and then N, E. E like this. That would mean B is one element and E is another element. Below the symbol is usually the name, and then you have your mass number, which is in a decimal. Make sure you round it. How do we find items? One thing, you're going to have to be able to look at the element block, know the atomic number, the mass number, of course, but you can just read it off there. You need to know the symbols. But you also have to be able to look at each element and determine the protons, the electrons, and the neutrons. The number of protons is the atomic number, and the number of electrons is whatever you write for protons. So the atomic number will be protons and electrons. This is because atoms are neutral, so positive must equal negative. To get neutrons, you're going to take your mass number that you've rounded, and you're going to subtract the atomic number from it. So let's see this in action. Hopefully you have your periodic table in front of you so we can do this. All right, the first element we have is neon. Of course it's going to be neon. I use neon for a lot of things. It's my favorite element. The symbol for neon is Ne. You can see big letter, lowercase letter. Now if you look at your element block for neon, the atomic number is 10. Then mass number. Mass number up there says it's 20.18. But we have to round that. So you round it to the nearest whole number. So you look right here. This says it's below 5. So we just keep the 20. 20. Number of protons. Number of protons is whatever the atomic number says. So since the atomic number says 10, the protons are 10. Electrons, whatever the protons say is what the electrons say. 10. The number of neutrons is a little difficult. We're going to take our mass number, which is 20, and subtract our atomic number from it, which is 10. And you get 10. All right, pause real quick. Find boron. Try to figure out these numbers. I'm going to count to 5, and then I'm going to continue. Make sure you pause. 5, 4, 3, 2, 1. All right. Hopefully you found boron. I have a little rhyme with it. I say boron the moron. It's just weird. All right. The symbol you would have found to be B. Then the atomic number, if you looked above the B, you would have saw 5. That's the atomic number. The mass number is 10.61, but we need to round that. The 6 would make this go up 1, so the mass number is 11. Protons. Whatever you write for atomic number, you write for protons. Whatever you write for protons, you also write for electrons. Neutrons. This time we're going to do 11, because that's the mass number, minus the atomic number of 5. And 11 minus 5 is 6. If you notice, the neutrons does not always have to equal protons. The neutrons are neutral. They don't come with a charge. They are just there. They're there for mass and some other stuff. This means this is because of the mass number. I hope you learned a little bit today. Go out, practice, look at the periodic table, try to figure out the protons, neutrons, electrons of all the different elements that you're required for. When I teach physical science, my students have to be able to do it for the first 20 elements, but it's all up to your teacher. But you learned something today, hopefully, and I'm Mr. Norris, and I'm out for this video.